Hi. Now we will look into different set operations like union, intersection, set difference, symmetric difference, and complement. Um, some of these operators are binary operators, except one, which is complement. Complement is a unary operator, means the operator that is going to be applied on a single set. But other operators like intersection operator or union operator or set difference or symmetric difference, they are binary because they are applied on two different sets. So you can think of it in this manner. Op is your operator that can either be union or intersection or set difference or symmetric difference. So this op is an operation or operator that can be either union. This is a symbol for union. This is a symbol for intersection, union intersection. This is the symbol for set difference. This is a symbol for symmetric difference. Okay, and the two operands, the left operand and the right operand, they are going to be sets. So this is operand 1 and operand 2. So left operand 1 and operand 2. So op 1 and op 2, they are sets. Op 1 is a set and op 2 is also a set. They are sets. Operands is set and the operations are set operations. Set operations being applied to two sets. Now, what are these operations, different operations? That's what we are going to see one by one. Okay, let's start with intersection first. These are two sets, A and B. Okay, and intersection means that it will return a set that will have elements which belongs to this region. Means if you have set A and set B, the intersection of set A and set B means that you have all the elements that are in both A and B. So such that X not only belongs to A, but it has to belong to B also. Means that A intersection B, when you apply the intersection operation between two sets A and B, then this whole thing will give you a set, or this whole thing is a set. The set operation, when it is applied between two sets, the ultimate result is that of a set. So A intersection B is a set, and the elements of this set are the common elements of A and B. Okay, so A intersection B, the elements are elements of this set. Elements of this set are the common elements. The common elements of A and B. Common elements of A and B. Okay. For example, if A is, let's say, 1, 2, 3, 4, 5, and B is, let's say, 3, 5, 7, 9. Then what is the set A intersection B? A intersection B is a set, the elements of which are the common elements of A and B. What are the common elements between A and B? 3 is present in both sets. 3 is an element in both sets. 5 is an element in both sets. So A intersection B is 3 and 5. 3 and 5. If you just see any arbitrary two sets, this is how you represent two arbitrary sets. And all of these different set operations, whether it's intersection or union or set difference or XOR, symmetric difference, all of these different set operations are actually giving you some region from the Venn diagram. Just look at this. Okay, I will show union here. So let me just draw an arbitrary two sets here. So you can see how many different regions, because of these two sets, how many different regions are possible. One of the possible region is this region, which is the common portion. And for to get this element, all these elements, you have intersection operation. So your intersection operation will return a set that has all the elements in this region. Okay. Similarly, all other set operations will give you some of the region from this diagram. The union operation, which is the second operation that we will study. So second operation is union operation. So union operation will return you what area of the means elements from which region, everything. Uh, Intersection gives you this portion, right? Intersection gives you this portion, the common region. Union will give you all the elements that is in A or it is in B. It will just return everything. Okay, so what is a union? A union B. A union B. This is equal to all the elements X such that X belongs to A or X belongs to B. So think of this. If your set A contains n elements and set B contains m elements, okay, and they happen to be disjoint sets, means there is no sharing area. Okay, let me draw a disjoint set. If the number of elements in A is equal to m and number of elements in B is equal to n, then what is the number of elements of A union B? A union B will have all of it. All of it. So the number of elements in A union B is equal to m plus n. This is in case of disjoint sets. In case the sets are not disjoint, which is this arbitrary sets we are taking, what will happen? Let me take one example and show you. Let's say A is 1, 2, 3, 4, 5, 6 and B is 5, 6, 7, 8. Okay, then what will be A union B? A union B means every element from A and B. So you can just directly write the elements of A and B. Of course, the order does not matter. So you can reshuffle if you want. But the elements are from A and B. But if you just straight away take the elements of A and straight away takes the elements of B, 5 and 6 are going to be written twice because they are common elements. So when you are listing all the elements of A, one time you will write 5 and 6. And when you are listing all the elements of B, second time you will write 5 and 6. So 5 and 6 will be written twice. Okay, and duplicates are not allowed. So let's say you will write all the elements of A 1, 2, 3, 4, 5, 6 and then all the elements of B 5, 6, 7, 8. Of course, when you are writing your set in this manner, you will correct yourself. You are not going to write 5, 6 twice because duplicates are not allowed in sets. Means duplicates are ignored in sets. Okay, but you cannot say that the number of elements in A union B for this case, in case when the two sets have some elements in common, they are not disjoint sets. You cannot directly say that this is equal to this is equal to number of elements in A plus number of elements in B, because that will be wrong. You can write this. You can say this in case of disjoint sets, because in disjoint sets, saying this is akin to just listing elements of A and elements of B without taking care if any element is coming twice because of the common element. So this goes fine in case of disjoint sets because there is no common element. When you list all the elements of A, then when you list elements of B, no element is going to come twice because there is no shared elements. There is no common elements. So in this case, this does not hold actually. So in number of elements in A union B is how much? Is going to be 8. You can see for yourself number of elements in A union B is 1, 2, 3, 8. This is equal to 8. But what is the number of element in A? 6. And what is the number of element in B? 4. So 6 plus 4 has to be 10. So the correct formula in case of A union B to find the cardinality of A union B set is number of element in A plus number of element in B. Then I am going to subtract number of elements in A intersection B. When you subtract it one time, so what happens? I want everything, right? A and B. I want everything. I want everything. So while listing all the elements of A, you have included these elements. Okay. Now you want every element of B also. Every element of B also. So far good. But now again you did this because these are elements of B also. So you are counting this twice. So because you are writing it twice, or when you are calculating the number of elements, you are counting it twice. That's why I have subtracted with A intersection. Number of elements in this region, I have subtracted that. So as to not count the same element, the common element twice. And this formula is called as inclusion-exclusion principle. This is principle of inclusion and exclusion. Inclusion-exclusion principle. So this is inclusion-exclusion principle. Now I told you about the Venn diagram. So in this Venn diagram, this is about two arbitrary sets. Any two arbitrary sets, that's how it is represented by two circles, and there's going to be one intersection part. But these are the Venn diagram for two sets which are disjoint. From the arbitrary sets, you will come to the solutions. From the arbitrary sets, you will come to the solution. Here also from the arbitrary sets, I come to this solution. This is a general result because in case of this disjoint sets, the number of elements in A intersection B will become 0. So this becomes this only. This becomes this only. So this is the general result. Okay, holds for all times. So when it becomes disjoint, then this term is 0. So for a general result, to get a general result, you take two arbitrary sets to get to a general outcome, or so as to get to a general result. You use the arbitrary two sets in this manner, and not you don't take these special cases. Like this is one special case where A is a subset to B. These are the special cases. For these special cases, you just fit that special part. Like in this case, A is a subset of B. Then A union B is nothing but B. When A is a subset of B, then A union B is B. Then what is the number of element in A union B? It has to be number of element in B, right? See if this formula holds for that or not. The number of elements in A union B is equal to number of element in A. Okay, no problem. Plus number of element in B minus number of element in A intersection B. And number of element in A intersection B is the entire A. So this becomes number of element in A plus number of element in B minus number of element in A, which is nothing but number of element in B. That's why whenever if you want to come to a solution using Venn diagram, you use these two sets. This is how you will draw two arbitrary sets in Venn diagram. every set operation will give you elements from some region. You know what intersection will give? You have seen that. What union will give? It will give every elements. Now A minus B, A minus B, it will give those part of A, those elements of A, it will give this region. Those elements of A apart from those elements which are common with B. So A minus B will give you A minus something. So you are not going to return all the elements of A. Some elements of A you are going to remove. If this is your operator, which is minus, and left operand is A, then A minus means that those elements of A are going to be removed that is present in this set, that is present in B. Okay. If this is your two arbitrary sets A and B, then A minus B is this portion. Similarly, what will be B minus A? This portion. Okay. So B minus A is equal to, from the set B, you don't want to include those elements that are in A. So from the set B, from this whole set B, you don't want to include this part. So X such that X belongs to B, and X does not belongs to A. This is your set difference. Next is symmetric difference. Thank you.